Hello, my name is Ryan Wajadi, and I represent Meteor Studio at Arizona State University. Today, I'll present Work in Progress Specific Key of Water Experiment, Augmented Reality Chemistry Lab. Augmented reality is becoming more widely affordable and accessible to the general public. We took advantage of augmented reality's affordance to create a virtual chemistry lab experiment. With the use of augmented reality, students have the capability to have an entire lab experience from the comfort of their homes. It also allows students to utilize expensive and hazardous equipment, not typically at their disposal. For our Works in Progress paper, we chose a lab experiment commonly performed in middle school and high school chemistry courses. We selected the specific heat of water experiment, which determines the heat capacity of water through its change in temperature. The purpose of this lab is to display the high heat capacity of water and teach students how to calculate specific heat through graph temperature points. Specific heat demonstrates how substances with higher heat capacity require more energy to increase the temperature. This serves a purpose in determining what substances can be used in regulating heat and how much energy is required to heat or cool a substance to desired temperature. In real-life use, water and other high specific heat coolants are often used to regulate the temperature of car engines. We predict that with the use of augmented reality in online chemistry courses, it will help increase academic performance and create a more engaging curriculum. Students will be able to freely interact with lab equipment and visualize realistic fluid dynamics, which will hopefully make the experience feel realistic and make online chemistry more enjoyable. Once in the app, the user first has to scan a predetermined image target to display the augmented chemistry lab. The user then has the ability to dispense a given amount of water into the virtual beaker and begin the experiment. The experiment, however, will only begin once a bunch of burners is on and the simulation is running. Students should then record the temperature of water in equal intervals, which can be made easier with the play pause functionality. While in the app, the user should also record the heat output in joules per second, the mass of water, and the time it took for the water to boil. All of these values will later be used to calculate the specific heat of water. In our experiment, once the water reaches 100 degrees Celsius, it will begin to steam, emulating the boiling of water. Students will then know that the experiment has ended, and they should continue by plotting the recorded temperature points. They should get a positive linear slope that plateaus once the temperature reaches around 100 degrees Celsius. To calculate the specific heat of water, we use the heat capacity equation C is equal to Q divided by M times delta T. Using the constant 1000 joules per second multiplied by the total time of 210 seconds to reach boiling point, it will equal 210,000 joules, which gives us our Q value. We then divide Q by the mass of 500 grams times delta T, which is 100.33 degrees Celsius, which gives us a final value of 4.2 joules per grams times degrees Celsius. This value is similar to the actual heat capacity of water, which is 4.18 joules per grams times degrees Celsius. To best understand the benefits of augmented reality in online chemistry education compared to the traditional remote learning, we considered other augmented reality research. In a similar research article, they developed an augmented titration experiment, which also utilized interactive fluid dynamics. They found through user studies that using augmented reality in conjunction with a titration lab gives the user a better understanding of the experiment and helps the user feel more comfortable around chemicals. In another article, they performed a study with 100 7th graders utilizing augmented reality learning to conclude that augmented reality significantly improved academic performance and improved attitude towards student education. We plan on producing a finalized version that could potentially be used in online chemistry curriculums. We will continue on developing on newer and older generation smartphones and tablets. Furthermore, we also plan on improving our UI design and adding warnings if the user doesn't follow proper precautions. To direct students, we will work on developing a procedural screen which can help guide students through the experiment. To create a more interactive experience, we plan on utilizing gesture control and cylindrical targets, which can help make the experiment more immersive. Finally, we intend on performing user studies with middle school and/or high school students to study the effect of augmented reality on learning outcomes. Thank you for watching our presentation.